Hey guys, welcome back to another video. This time we're going through all of the A-level maths past papers. We're starting with June 2024, paper 1, which seems like a common sense thing to start with. And we're going to go through every single question. We're going to go through the examiner's reports to make sure I identify exactly where students went wrong in the 2024 exam series, exactly where you get the marks, to ensure that you don't make any silly mistakes and so you can get that A-star grade. If you're interested in joining any of my A-level maths classes or A-level physics classes, then there is a link in the description to my website and also to my email address. And if you want one-on-one tuition, that is also something I can do as well. But without further ado, let's just jump straight into the video. So for the first question, we have g of x is given by this cubic function here, and it gives us that k as a constant. We have k here and over here. It says, given that x minus 3 is a factor of g of x, find the value of k. Now, this seems like a fairly simple, straightforward question, but again, you get marks for very specific steps in the question. So if it's a factor, then what that means is g of 3 should equal 0. So remember, you need to find the root of that solution. So x minus 3 is 0, so x equals 3. When you sub that in, you should get 0. So now we actually need to do the substitution itself. And that's where our first mark comes from. So 3 cubed minus 20, 3 squared plus k plus 17 times 3 plus k, in theory, should equal 0. And then, of course, we can just use a calculator to work out all of the numbers. So that's what I'm going to do. So I'm going to do 3 times 3 cubed minus 20 times 3 squared. And I'll expand that in a second. In fact, we can also do the plus 3 times 17 if you think about it, because when we expand this, we're going to get 3k plus 17 times 3. So let's do that as well. And we get minus 48. So we get, in total, we get minus 48. In terms of k's, we get 3k plus another k, so that's 4k, equals 0. So going to be 1 mark for this. We get another mark for simplifying the expression, and then lastly for solving. So move the 48 to the other side, and therefore k is equal to 12 for the final mark. But you do need to actually show the substitution. Jumping straight to here does lose you one of the method marks because you're not showing that you've used the factor theorem. And that seems a bit harsh, but again, write out all of the steps. So I'm really looking forward to this question because part B comes up not all of the time, but it comes up maybe 70% of the time, and students always come to me and they ask, how do you know with this stuff, whether it's x is minus 2 over 9 or 1/3 or 3 or whatever, how do you know when you can and can't use an expansion? Now in the textbook, I don't think it's really given, there's no real reason given for it. So what I'll do is I'll tell you the reason, and then I'll actually show you why, which is the really important thing. But first of all, we have a binomial expansion, but it's with a fractional power, which means this is actually an infinitely long series, right? It never ends because when we subtract 1 from the power, we never get to 0. So how do we do this? Well, all you need to do is, it says the first 4 terms, so we're going to have that like 1 plus and so on. So if I say 1 minus 9x power half, remember that this first value here should always be a 1. If it's a 2, you have to factorize out 2. If it's a 3, you factorize out 3, and so on. You have to make sure it's just 1, nothing else, okay? And in terms of where you get your marks from, you get them from writing this. So the first value is always 1, then it's plus n times x, then it's n minus 1 over 2 factorial times x squared, plus, and then you follow this kind of pattern where you're constantly subtracting 1 from the numerator. You're adding another term that's 1 less in the numerator, adding 1 to the denominator, and that goes on forever. And the reason why it goes on forever is because, again, we never reach 0 with the power. But if you look at it, because we're squaring it, cubing it, and so on, the value of x is getting smaller and smaller and smaller. So that's also a very important thing to consider. So nx is going to be a half times minus 9x. Now, I personally always do this in multiple steps. I never, ever, ever skip steps on this because it's very easy to make a mistake. And it says the first 4 terms. So let's keep going. So we have a half, n minus 1. Again, you could write a half minus 1, or you could write minus a half. It's totally fine. I will say that some students in exams make small mistakes when it comes to this. So it might be worth doing that and then just doing the whole thing on your calculator. then minus 9x all squared. Remember, the coefficient of x is also in the bracket, so it is a minus 9x, not just an x squared. And we need one more term, so let's do that. We have a half, minus 1, a half, minus 2, all over 3 factorial, times by minus 9x all cubed. And now here's what I would do. So of course the first term is just 1. I would enter in a calculator. Maybe the first one I wouldn't bother just because I'm a little bit lazy, so that'd be 9 over 2x. I would also leave it as fractions. I wouldn't bother doing anything like that. And now, here's what I mean by using a calculator, is I'm going to enter everything except, of course, the x. So we have a half. In fact, I'm just going to make that 0.5. 0.5 minus 1 over 2 factorial. 2 factorial is just 2 because it's 2 times 1. But if you really want to put the factorial there, you get, shift. There we are. And then we have the minus 9 squared. Now we can't put the x in there, so that's why I put that. So all I need to do is remember that that's minus 81 over 8x squared. And again, keep going. So the good news is we only really need to add to this. We don't need to do anything kind of crazy. Minus 2 over 3 factorial, and we're going to change that to a cubed. Whoops, where? I forgot to close the bracket here. Minus 729 over 16x cubed. And again, that didn't take me more than 3 minutes, and it's a 3-mark question, so that is valid, okay? Make sure that you take your time with that, because in my opinion, binomial expansion is 3 marks. It's always just a process. Now, for part B, give a reason why. Here's the reasoning why. When it comes to binomial expansion, we always have it in the form... In fact, I'm not going to use n because that's a bit silly, because we're going to use n for the power, right? We always use... It's always in this form, right? 1 plus bx to the power of n. In this case, b is negative 9. And we always use it. Now, bx, the modulus of it, has to be less than 1. Which means if I rearrange it, the modulus of x needs to be less than 1 over b. So in this context, if b is 9, then this needs to be less than, the modulus of it has to be less than 1 over 9. Which if you look, 2 over 9, so if I write out this full expression here, that's minus 1 over 9 less than x less than 1 over 9. Since this is minus 2 over 9, it's outside the range. Minus 2 over 9, outside range. Therefore, invalid. Now, I should talk to you about why this is. The reason for this is when I times x by 9 in this context, so if I work out what bx is in this context, it's going to be 9 times minus 2 over 9, which is minus 2. Okay? Now the problem with that is if it's minus 2, then that means all of these values, if I sub in x equals minus 2 over 9 into all of these, can you see that it's always going to give me a number bigger than 1? Right? So for example, minus 9 times minus 2 over 9 is going to give me positive 2. That's going to give me positive 2 squared. That's going to give me positive 2 cubed. The problem with that is that means that each of these terms are getting bigger and bigger and bigger, which means the binomial expansion is a divergent series. It doesn't converge to a specific value. If it diverges, that means when this series will always be infinite. Because don't forget, this goes on forever. So it's just going to keep getting bigger and bigger and bigger and bigger up to infinity. The thing is, that's useless because if it's infinity, then that means this is always infinite, which doesn't make any sense. When we use binomial expansion, we use it as an approximation, right? So for example, if I wanted to work out, I don't know, the square root of 2 for argument's sake, I don't want to get an answer of infinity, right? Because that's pointless, it's not correct. So the reason why bx has to be less than 1 is because it creates a convergent series that has a sum to infinity, okay, that we can actually calculate. When it's bigger than 1 or less than minus 1, it creates a divergent series that has no sum to infinity. which means we can't actually use it to make approximations about things. That's why x is minus 2 over 9 should not be used in this expansion for the square root of 3, because if I sub it in, this goes off to infinity. That's the reasoning. Okay, so we have a iteration / in this case Newton-Raphson method question, which is fun. So f of x equals x plus tan half x, where x is between pi and 3 pi over 2, so 1.5 pi. Given that this has one root, alpha, show that it lies in this interval. Now, all we need to do, fairly simple, you get 2 marks for this. Now bear in mind, when you get 2 marks, you do have to give a conclusion. Just subbing in the values does not give you both marks, it gives you 1. We're going to sub in f of 3.6, and we're going to sub in f of 3.7, and see what we get. Now, where were the mistakes in this case? The first one is doing it in degrees. If you leave your calculator in degrees mode, you actually don't get a valid answer. Both of the solutions are actually the same sign, which is not good. So instead you need to make sure you're in radians mode. How do I know? Because it says the domain is in pi, it's in radians, which means, of course, we're in radians mode. Angle unit, radian, and then literally just subbing in those values. So 3.6 plus tan, said tan, immediately presses sign, 0.5 times 3.6. And I get negative 0.686. And if I just quickly change that to 3.7 now, I get 0.2119. That is 1 mark. So this is less than 0, that's bigger than 0. The conclusion you have to make, and you have to do this every single time, is that a change in sign, assuming the function is continuous, which it should be, a change in sign implies the existence of a root. So, change in sign, and function is continuous. That's the part that a lot of students miss out on, and you do lose the mark for it. Is continuous implies existence of a root. And that's where you can get both marks. The function has to be continuous. So for example, if I have the graph of 1 over x, for example, again, there's no solution at 0 because the function isn't continuous, despite the fact that it goes from positive to negative. There's no solution where it equals 0 because it's not a continuous function. A continuous function, probably the simplest way to put it, is it's a function that you can draw without taking your pen off the paper. Now you might say, but tan has those asymptotes, but they don't have asymptotes in this region here, in this domain. It's continuous in that domain. It's not continuous over all values though. So again, that's something you need to kind of be aware of. And for part B, because we need it for the Newton-Raphson method, we have to find the differential of this. So when we're differentiating this, the first part is really nice and easy. Because there's an add sign in the middle, we can treat them as 2 separate things. So I can differentiate just x, and I can differentiate just tan half x completely separately. So if I differentiate x, I just get 1, so that's nice. Now for the tan half x, again, one of the things you need to know is that when you have tan x, when you differentiate it, it becomes sec squared x. Now the key thing here that's kind of often missed is that if it's tan of a function of x, then when you differentiate it, it's the differential of the function sec squared of the function. So what do I mean by that? Well, this isn't just going to be sec squared x when I differentiate. It's not going to be sec squared half x. It's going to be, I differentiate this, which gives me a half, right? Half x differentiate gives me a half. So a half, sec squared, and then the original function again. And this applies to every trig function, the log functions, all of it. The e to the x as well. It's actually e to the f of x, and you differentiate f of x. So do keep that in mind. And again, there you go. 2 marks for that is really, really nice. You get a mark for getting sec squared a half x, even if you don't get the half in front, which is interesting. So as long as you get sec squared half x, you get 1. and you get the second mark for getting the whole thing right. And now for the slightly annoying method, which you do get given on your formula sheet, at least you did last year. I don't know about this year or whenever years we're going to do it in English. Using 3.7 as the first approximation for alpha, so let's call it alpha, I'm going to call it alpha 0, 3.7. Apply the Newton-Raphson method once, thank God, to find a second approximation for alpha, give your answer to 3 decimal places. Now, in terms of the Newton-Raphson method equation, again, you should be given this, but, you know, if you're watching this in the future, I don't know if they want to get rid of in formula sheets, so we'll see what that is. You take your value for alpha n, and you subtract the original function with alpha subbed in, so the original function being this, and you divide it by the differentiated function with, in fact I should write alpha n, whoops, there you go. So if I want to get the second approximation, alpha 1, all I'm subbing in is 3.7 minus, and it was x, so that's 3.7 plus tan a half times 3.7 over 1 plus a half sec squared half times 3.7. Wonderful. And remember that sec is 1 over cos, so we can sub that into our calculator nice and easily. Let's do it. The other thing you could do, by the way, is you could sub the 3.7 in separately into those two equations, get the answer and then sub it in, but you know, I want an exact answer. So 3.7 subtract fraction 3.7 plus tan 0.5 times 3.7 close bracket over 1 plus 0.5. Now what I want to do here is I'm going to put it in brackets. This is going to look a bit disgusting, but 1 over cos squared, so cos 0.5 times 3.7 squared. Or we could do it as, I mean, the other thing we could do, by the way, is we could also have it as outside the bracket squared. That would also work. And we get 3.672. How many decimal places was it? 3, so 3.672. And that's it. So for 6 marks, I don't think it's too bad, but there's a lot of little finicky details where you can make mistakes. But let's move on. I absolutely adore these questions, whether it's with sin x, cos x, whatever, because again, I think that they're nice and 3 marks. Now, in terms of what the differentiation from first principles is, all you need to do is you're taking a limit as h tends to 0 of f of x plus h minus f of x, minus f of x all over h, and that's it. So if we quickly sub that in, I'm not going to write the limit every single time just because I'm a little bit lazy, but as long as I put it in for the end, that should be okay. My f of x is x squared, which means my f of x plus h is just x plus h all squared, and we get something like this. A common mistake that I see with something like this is students trying to cancel h's out early. You're basically going to cancel h's like the second last thing that you do. The first thing you need to do is expand and simplify. So that gives me x squared plus 2hx plus h squared minus x squared over h. Simplify that again. We've got x squared, take away x squared, so it's 0, so we have 2hx plus h squared over h. Again, we don't want to do the limit yet, because if we make h 0, we're technically dividing by 0, which is a big no-no in maths. So divide through everything by h, so that becomes 2x, because the h's cancel. If you want, you can cancel it like this. We get 2x plus h. And now, for the very last step, we're taking the limit as h tends to 0 of 2x plus h. So if I make h equal to 0, then I just get 2x. So that means dy by dx should be 2x. Not too bad. Again, they can make it x cubed if they wanted to, which makes it slightly longer but no more difficult. They can also give you sine and cos, where you have to use the addition rules to figure it out. But again, I don't think they're too crazy in my opinion. So yeah. So the function f is defined by this fraction here. We have to show that when you differentiate it, you get a quadratic divided by x squared plus 4 all squared. So you can use product rule and chain rule for this, but honestly the quotient rule might be the easiest. The reason why I say that is the product rule and chain rule is easier if you don't have to give it in a specific form. If you use the product rule and chain rule, you might not get this form very easily. It might require some tricky algebra. So instead the quotient rule might just be our best bet. If you remember, the quotient rule is that if you have two functions like this, then when you differentiate, you get du dx times v minus u dv dx. That's meant to be a v all over v squared. So in this context, our u is 2x minus 3, and our v is x squared plus 4. Now in the product rule, it didn't matter which way around u and v were, but in the quotient rule it does matter. V has to be what you're dividing by, the divisor, and u has to be the numerator of the fraction. It has to be. So if we scroll down now, all we have to do is work out du dx. Nice and easy, it's just 2. And dv dx, nice and easy, it's just 2x. And then just sub it into that formula. In fact, I'm going to write f prime as well, because I think that's the notation they wanted, right? F prime, good. So we have du dx times v, so we have 2 x squared plus 4, minus, and notice I'm using brackets everywhere to make sure that I'm not going to make a mistake when I expand. Again, it's really, really easy to do. So u, which is 2x minus 3, times dv dx, which is 2x, all over v squared. And luckily we don't need to actually expand this, because if I remember rightly, the answer had that as the denominator, didn't it? Yep, so we don't even need to worry about that. It's just expanding and simplifying the top. So we get 2x squared plus 8 minus 4x squared, because don't forget it's 2x times 2x. And that's going to be minus 3, so positive 3 times 2x is 6x. Was it negative at the front? It wasn't negative at the front. Well, I mean, don't forget a can be a negative number. That's completely fine. And then we have x squared plus 4 squared on the bottom. And lastly, but not least, let's simplify it. So 2x squared minus 4x squared is minus 2x squared. I remember that I wanted the x squared at the front because of this. Again, don't give the examiners any reason to not give you marks. Then it's the 6x. Then it's the 8 all over that. So not too crazy, right? Not too crazy. 3 marks is not that many, if I'm being honest, but you know, it is what it is. Now for part B, I really like this question, hence using algebra. Hence, don't forget, whenever they use the word hence, what they mean is use part A. So when they say hence, I'm immediately looking at this. Using algebra, find the values of x for which f is decreasing. You must show each step in your working out. There's a few ways to do this. Now I'm going to try and show you the most mathematically rigorous way possible. For those of you that are in my lessons either at school or in tuition, you know that I don't like the idea of cancelling stuff out, and I'm going to show you why in a second. Now first of all, what is this? This is the gradient function, right? So it's telling us if the original equation is increasing, if it's positive, or if it's decreasing, if it's negative, or if it's staying completely the same when it's 0. So if we're looking for the values for which it's decreasing, we're looking for when this is less than 0. Because a negative gradient means you're decreasing, right? If you ever get confused on that, think of a straight line. That's a decreasing gradient. That's an increasing gradient. Which one's increasing, which one's decreasing? Well, the negative gradient means the overall graph is decreasing, right? And a positive gradient means that the overall graph is increasing. That's it. Don't forget, the gradients for a straight line and for any other function mean the same thing. Okay? They still tell you if it's increasing or decreasing. It's just how complex they are. So we're trying to work out when this thing trying to work out when this thing is less than 0. Now, a really common thing for people to do is they'll times both sides by x squared plus 4 squared, and there you go. Then you just have a quadratic. And I'm going to be honest with you, that works in this case, and it works in a lot of cases. But in general, you do not want to cancel anything that has x's in it. The reason is you miss values. So there's a really common thing that I see where it might be something like, oh, I don't know. And one person will just go, oh, cancel the sine x. Well, no, then you miss values, right? You miss loads of values, in fact, because sine x equals 0 is a valid solution. Then you get x is equal to 0, 180, and 360, and so on. That's why you don't want to cancel values out. So instead, I'm going to show you that we still get the same next line, and why this works in this case specifically. Cancelling works in this one case specifically, but it doesn't work in all cases. And again, I've seen a lot of people online, and even in mark schemes, where they jump straight to make this less than 0. They jump straight to it because they don't explain it. Here's the reason. If I want this fraction to be less than 0, then I need to think for a second. How do I make a fraction negative? Well, you can either have a positive numerator and a negative denominator, or you can have a negative numerator and a positive denominator, right? Cool. So do we need to check all of them? Well, let's think for a second. Let's look at this denominator. This is looking a bit suspicious. X squared is always positive. I add 4, always positive. Anything squared is always positive unless you're doing complex numbers. So this denominator is always positive. Always. So I don't need to worry about this first combination because I can't have a negative denominator in this particular function because it's being squared. Which means the only combination is when this top thing is negative. So in other words, I only need to check this top value here. That's why, technically speaking, we should actually check the positive thing. We should be setting x squared plus 4 squared is bigger than 0, and we should be checking this. We should be checking both. Now, the reason why even in mark schemes they don't necessarily use both is because they know that this inequality encompasses this inequality as well. So let's say the answer to this one was x has to be bigger than 1, but in this one is x has to be bigger than 0. Well, the answer then is just x is bigger than 0. The reason why I mention this is a lot of times when students are doing exam questions, basically to get students to A's and A stars, I just get them to ask me loads of exam questions. And the reason is because sometimes in mark schemes they skip steps, because a mark scheme is not designed to teach you how to do a question. It's designed for the examiner to know where to give marks. That's it. So in this case, why do we not do this one? It's probably because the solution to this equation here is encompassed by this one over here. But you can't assume that. And in fact, there are questions where the mark scheme has 2 different inequalities. And the student's like, why? I made the top equal to 0. Because that's not the answer to the question. In this case, we have to check both inequalities. So, in fact, in all cases, we have to check both inequalities. So let's do it. For this top one, if we square root both sides, we get x squared plus 4 is bigger than 0. Then we get x squared is bigger than minus 4. Then when I square root, there's no solution. No real solution. Which is why I don't need to use that one. Because x squared plus 4 squared is always bigger than 0, which means it never equals 0. So now let's look at the negative one. Okay? So we've accepted for all real values of x, x squared plus 4 squared is bigger than 0. Okay? So we don't need to worry about that one. Now for this one, we have to actually do something. The good news is, because it doesn't specify in the question, we can just use a calculator to work this out. We do not need to do it properly in air quotes. But let's see. I'm going to divide everything by 2. We get minus x squared plus 3x plus 4 less than 0. And then if we factorize that, it'd be what? X plus 1, x minus 4. That would make it equal to 0. Let's factorize out a minus 1 as well. So now we have, it's going to be minus 1. Now it's going to be the x plus 1, x minus 4. It's less than 0. So if I draw out that graph, we have it crosses at minus 1 and 4. So over here and over here. But because it's a negative quadratic, it's going to be a big sad face. Dang it. Alright, let's say 4 is over there. And we're looking for the values when it's less than 0. So we're not looking at this value, we're looking at these two values. So either when x is less than minus 1, or not and, or x is bigger than 4. That's your final solution. Now again, hopefully you can accept that any real number is encompassed by minus 1 and less than minus 1, bigger than 4, right? Because numbers less than minus 1 are real numbers, numbers bigger than 4 are real numbers. So I don't have to write, I mean if you want you could write x as any real number, but that's just the solution there. But again, please, 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 with these functions, don't just cancel stuff, you have to check it as well. Just in case you get that one random question in your exam. One of my favourite topics for some reason, the modulus function and all of that fun stuff. I also think it's because, again, there's a lot of misconceptions that can come and misunderstandings that can come from this. So hopefully I'll be able to fix that for you a little bit, maybe. So, figure 1 shows a sketch of a graph with the equation 3x minus 2 in modulus sign plus 5. Find the coordinate of P, which is the vertex over here. So when you when you do this, what is that vertex? Well, if we subtract 5 quickly, then that's going to be the point when the graph crosses the x-axis. And the reason why it's a vertex is because of the modulus sign. So it makes it positive, right? So it bounces off. So if I just draw the line of 3x minus 2, that would be what the graph looks like. And then if I put a modulus sign around it, it would then bounce off like this. So the only reason why it's been moved up is because of the plus 5 on the outside. So when does it cross the x-axis? Well, that's when the thing inside this bracket here, when this is equal to 0. I just realised I put the 3 on the inside, not the outside. Whoopsie daisy. The 3 should be out here. So when x minus 2 is equal to 0, which is obviously 2. Now lastly, the y-coordinate, well the y-coordinate would normally be 0, right? Because if I make y equal to 0 here, that's how I got the x is equal to 2. But the problem is it's been shifted up by 5. So then it'd be 5. There you go. Not too shabby, hopefully. And now we get on to the fun bit. I love these two questions. And they come up really, really frequently. And again, it's all about understanding. The first thing I really despise is when some people say, oh, you just make it negative and positive. In some cases, sure. But not in all cases. And what's even better is you can actually find solutions much more quickly if you actually just draw the graphs out. So we've already gotten this graph drawn for us, which is nice. Now, even if they gave you just like a normal equation, like, I don't know, x minus 4 equals... I would always draw out both of the graphs, because then you can see how many times they intersect. Because they don't always intersect twice. Most people assume, and by the way, that's why people make it positive and negative, right? Because there's two solutions. They don't always intersect twice. They might intersect once, or they might not intersect at all. Or, if this was like a quadratic, they could intersect 3 or 4 times. And how will you know? You only know by drawing. So we need to now draw the 16 minus 4x. So again, when I say draw it, it's not that bad. 16 is the y-intercept, so we're going to say that that's like up here somewhere. And it's minus 4x, which means it should be steeper than the 3x graph, right? So if this is, let's say, that steep, then we are looking for something that's even more steep than that. So that's what we're going to do. We're going to draw something that's very, very steep, like that. And I believe there was a modulus sign around it, right? In fact, let me move that over a little bit just so it actually fits on what I'm talking about. So again, you can see it's steeper because it's a 4x instead of a 3x. And there was no modulus sign, so it doesn't even bounce off. So I could keep going, but there's no point, right? Because we know it's already going to do that. So in this case, How many times does it intersect? It intersects once. And because it intersects once, there's only one answer. Now the question is, when does it intersect? Now again, in this case, if you made this positive and negative, you would get the right answer, but you'd also absolutely terrify yourself. Because what happens if you make it negative, but there is no solution when this is negative? Well, you get a nonsense answer. You get something like 0 equals 0, or 1 equals 1. That terrifies students. And it terrifies them, which means they think they've done the whole question wrong, which means they leave it blank. Be careful. The reason why you don't get a solution, you get something like 1 equals 1 or 0 equals 0, is because you're making two things equal that aren't never equal. Right? So they're never equal, but you've made them equal. So of course you're going to get a nonsense answer. It'd be like me saying 2 equals 1. I can write that. It doesn't mean it's true. So if I make this, now the question is, which one is it? Well, if you look, this part of the black line is when the graph is a positive x. So that's when this is positive. So y equals 3x minus 2 plus 5. Why the minus 2? Well, because again, it's still going to intersect at minus 2 until we add the 5. Whereas this part of the graph is when it's y equals minus 3x plus 2 plus 5. How do I know? Because I can see that it's crossing at quite a big number. It's crossing at a higher number than this one, right? So it's going to be positive. So I can see that I'm not going to use this one. So again, you've made two things equal that are never equal. That's why you get a nonsense answer. If you draw it out, you'll know which two equations to make equal. We're going to make 3x minus 2 plus 5 equal to 16 minus 4x, and that is the only solution we have. So now I'm going to add 4x to both sides. I'm going to gather the like terms. So we get 7x plus 3 equals 16. Minus 3 from both sides, you get 7x equals 13. Divide both sides by 7, you get x equal to 13 over 7. So let's just check that. Good. 3 minus it. Perfect. Actually, one thing I've just realised is this is still in a bracket. So I need to be careful with that. So I need to change this ever so slightly. That would be a minus 6 plus 5, which makes it a minus 1. That makes that a 17. Okay, and then obviously we can get rid of this. So x is equal to 17 over 7. So again, I thought the brackets twice that round. That's not good. So yeah, again, the key takeaway from this is draw it out and decide if you want the positive or negative version of the equation. Because again, it might not be both. And if you do both, you might think you made a mistake. Now, here's a really, really good question. I love these ones as well. I love them because they do test real understanding of maths instead of just giving you a process to follow. And again, you need to draw it. You have to. I don't know how you do this without drawing it. You can't just do it algebraically. It says a line has equation y equals kx plus 4, where k is a constant. Given that it intersects the graph that we had originally at two distinct points, find the range of values for k. People always end up getting one of the values, not both of them. And let me show you how to do this. So again, what we're going to do is we're going to just delete all of this quickly. Now, kx plus 4, k can be a negative number. Okay? It can be negative. But why can't it be negative in this case? Well, if I try and make this, so kx plus 4, we know that this thing intersects at 5. So it's intersecting there. Now if I try and draw a negative gradient line, so something like that, the only thing changing in this case, because it's kx, the only thing changing in this case is this, the steepness of the curve. Okay? That's what you have to bear in mind. Now, when we do the steepness of the curve, we have to be very careful to check when it will be two distinct points. And before I do that, we should actually check what the y-intercept actually is, just to make sure we're getting an accurate value. Y-intercept is when x equals 0. So 0 minus 2 is minus 2. Make it positive, plus 2. 3 times 2 is 6, plus 5 is 11. So that's 11. So actually this graph should be quite a bit lower. And this does make a difference, by the way. Now, I can clearly see that I can't have a negative gradient. Why? Because it never intersects when it has a negative gradient. That's it, right? In fact, it can intersect once, but it can't intersect twice. Okay, remember this line, this blue line, goes on forever. In fact, to make that example make it a bit more obvious, I'm going to make the line ridiculously long. And now you can kind of clearly see, no matter how negative the gradient is, it will only ever intersect once. Now, when will it start intersecting twice? Well, I need to lower this a bit. That's the only downside with this. Well, it's still not intersecting, intersect once, and then anything bigger than that, it will start to intersect twice, right? So all I need to do is I need to work out what the gradient is when it intersects point P. Because anything bigger than P, it will start intersecting twice, right? So again, if I just show you that, intersects once, twice, 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 twice. So start with that. We know that the y-intercept is 0, 4. And we know that the coordinates of P are 2, 5. So all we need to do is work out the gradient of those 2 points. So we have 5 minus 4 over 2 minus 0. So that's 1/2. So one part of it is k is bigger than 1/2. And this is the value that a lot of people get. It's not the fully right answer though. Why? Well, there's something I skipped out on purpose. What if I keep making it bigger? I'm saying that if k is bigger than 1/2, it always intersects twice. Does that intersect twice? Does that? No. So there is a peak value as well. Now, what is that peak value? This is slightly harder to work out because you work it out using intuition, not a calculation. When will this no longer intersect twice? Well, it will stop intersecting twice when these 2 lines are parallel to each other. Because what's the definition of parallel lines? They never get closer together and they never get further apart. They have the same gradient. So if those 2 lines are parallel, they will never meet again. That's our upper limit. So when are they parallel? Well, the gradient of this this line here is 3, right? Because it's 3x. And I think it was, what was it, plus 11? I don't think it was actually. It was -1 or something like that. Whatever. The gradient is 3. So as long as the gradient is also less than 3, then they will always intersect at 2 points. Again, that is the part that a lot of people make a mistake on. Now, whenever you're doing modulus questions as well, you need to keep in mind that when you're doing that thing back here, when you're solving equations, you need to check, will they intersect at some far off point? Because even if the gradient is 2.9 recurring, technically, really far away, they will intersect again. So you need to keep that in mind. And you need to keep it in mind when you're doing solving equations as well. If the gradients are the same, they'll never meet again, there's not another solution. But if the gradients are different, they will meet a second time. So you need to take that into account. Same thing when you're doing this. And that is, again, the common mistake that people make with those 2 modulus questions. Okay, here we have a differential equation question. We have a cylindrical tank of height 1.5 meters. It's initially full and then it starts to leak from a hole at this point here. While the tank is leaking, the depth of the water in the tank is modeled by this equation, where t hours is the time after the leak starts. Using the model, show that h is equal to this expression. So, essentially all we're doing here is solving a differential equation, which is not too bad. All you need to do is separate the variables. So we're going to move everything with t to the right hand side, and we're going to keep everything with h on the left hand side, which is fairly easy to do. It's a nice and simple equation. And we're going to integrate both sides. Now, technically this should be h plus c, but I'm going to explain in a second why I'm not going to put the plus c there. Now for this one, you need to, once again, you differentiate what's on the inside here, which gives you minus 0.2. And you divide this by minus 0.2. If you were differentiating, you would just bring it to the front and you would times it by 0.2. E, and then that obviously stays the same, plus c. Now the reason why I've only put 1 plus c in this is because if I have a constant on the left and the right, I can just combine those constants, right? So let's say the one on the left was 3, the one on the right was 5. I can combine that to make 2, right? When I move it over. So I only need 1 plus c, and I normally put it on the right-hand side. So let's work that out. I don't want to do that in my head because I'm scared I'm going to make a mistake. Oh, come on. Minus 0.12. Gives me 3/5. Alright. I'm going to leave it at 0.6 because yeah, let's do that. And a common mistake that I see is students leaving it like this. Don't forget, we do need to actually work out what c is. Now, what do we know about this equation so that we can sub something in to work out what plus c is? Well, we know that it's initially full of water. Initially meaning t equals 0. The height would be the full height of the tank, which is 1.5. So let's sub that in. So t equals 0. We're going to get 1.5. This is going to be e to the power of 0, which is 1. So we just get 0.6 plus c, which means c is equal to 1.5 minus 0.6, which is 0.9. So our final equation is h is equal to 0.6 e to the minus 0.2 t plus 0.9 for the full 3 marks, which is very nice. And for part B, it says find the time taken for the depth of the water to decrease to 1.2 meters. Give it in hours and minutes. Again, a super common mistake here. Someone might get 1.6 hours and leave it as that. No, it's going to be 1 hour and however many minutes, okay? You can't leave it as just a decimal. So, it says for it to decrease to 1.2, so all we're going to do is make h equal to 1.2 and then solve the equation. This is part B. By the way, the reason why I'm writing the answer on the side is just so I don't have to scroll up and down to, constantly going up and down. So we have 1.2 equals 0.6 e to the minus 0.2 t plus 0.9. And we're going to try and solve for t. So what I want to do is remove everything that doesn't have a t in it to the left-hand side. So I'm going to minus 0.9. Then I'm going to divide by 0.6. 0.3 divided by 0.6 is a half, or just 0.5. Now, to get rid of the e, we're going to take the natural log of both sides. What the hell just happened? Okay. Let's scroll over to the side again. 0.5 equals, and if you remember, we're going to have ln e to the minus 0.2 t. ln and e will cancel each other out, so it just makes minus 0.2 t, which means t is equal to ln 0.5 over minus 0.2. Again, ln of a number that's less than 1 is going to give you a negative, so a negative divided by a negative. So don't worry about the negative in the denominator, it's to cancel the negative we're going to get in the numerator. So it is reasonable. Cool, we get 3.466, let's call it. That's in hours. So that equals 3 hours and, well, all we need to do is do 0.466 times 60, right? Because that's 0.466 of an hour times by 60, we get 28 minutes because it says give your answer to the nearest minute, so that'd be 28 minutes. Wonderful. Anyways, in the long term, the water level in the tank falls to the same height as the hole, which makes sense. Find, according to the model, the height of the hole from the bottom of the tank. So we're trying to find out what this value of h is. Now it says after, in the long term, so after a really long amount of time. So if we just sub this in quickly. I quite like this type of question because, again, it tests your understanding. Now, there's 2 ways to do it. I'll show you both ways. The first thing I'd like to point out, though, is imagine, what does the e to the minus 0.2 t graph look like? Well, it looks like this, right? And And what happens as we get bigger and bigger values of t? Well, it approaches 0. It doesn't equal 0, but it gets very, very close to 0. So in the long term, this first part of the equation is going to become really, really, really small. In fact, it's going to be approximately 0. It's going to be 0.000000000 going on forever. Which means the height in the long term is going to be 0.9 meters, which is the height of L. Because remember, it's not going to drop below L, because if the hole is there, what's going to cause it to leak beyond that point, right? Now, the other way to do it is, of course, and again, you have to be careful when you're doing this, is you can sub in a really, 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 really big number for t. So minus 0.2, and then let's just sub in something ridiculous. And we get 0.9. But again, you can just do it by visually looking at it. So as t gets large, this goes to 0. And we're just left with the 0.9 on the right. Okay, so we've got some function questions here. Very interesting. Now the first couple should be okay, hopefully. For fg of 2, it means you're going to sub in 2 into g. Then whatever your answer is, you're going to sub that answer into f. So, I mean, we can probably just do this in one step, right? So if I pull my calculator over, g of 2 would be 5 over 2 times 2 minus 9. I get minus 1. Now we're just going to sub in minus 1 into f. Minus 3. I didn't need a calculator for that, but you know what? I've committed, so let's do it. We get 1. Wow, shocking, right? Absolutely shocking. We get the answer of 1. Now finding the inverse function, again, it's very similar to how you would do it back in the old GCSE days. You're going to make g of x equal to y, and then you're just going to try and rearrange for x, and then just swap the letters around again. So times both sides by 2x minus 9. Then we're going to divide by y. Then we're going to add 9 over y. And then divide both sides by 2 would probably be the best bet. Yeah. You know, do I want to leave it looking like this? Do I want to combine it? It does say simplified fraction, singular. So we do need to combine these two fractions because it says simplified fraction, not plural. So all we're going to do is times the second one by y, top and bottom. So that'll be 5 plus 9y over 2y. So then our final answer is we just swap x and y, and we make x equal to g of minus 1. 9x over 2x. There we go. Perfect. Yeah, that wasn't too bad for part B. For part C, it says we have to find gf of x and then deduce the range. That's a really, really good question. I like that. There's a few ways to do the range. Range and domain normally do suck for a lot of students, at least for my year 13s they did anyway, and I don't blame them. I'm going to show you how I do it in this context. So, when it's a compound function, a composite function, I do something slightly different than what other people do, but it does work. So find gf of x. We're going to sub in f of x. So what that means is we're taking the function f of x and we're subbing it in for x over here. So if I just write gf of x quickly, we get 5 on the top, then we have 2 brackets, then all of 4 minus 3x squared. What was it, plus 5? No, minus 9. Good thing I didn't just guesstimate that. And we get 5 over 8 minus 6x squared minus 9. So we get 5 over, I'm going to say, minus 6x squared minus 1. I think that might be the nice way to put it. Yeah, that's probably the best way to put it. And then for part 2 it says deduce the range. So, let's have a think about how we can do the range. The range is there's quite a few different things you can do for the range. The first thing you want to check is there a domain? So can you see that we've subbed in f of x into g of x? The range of f of x, is now the domain of g of x. Because if you think about it, all of the values we get for f of x, we're now subbing into g of x. So the question is there any limit on this? So that's what we need to work out first. We need to work out what the range of f of x is first. Now this can be done in a few different ways. Since it's a quadratic, we are quite lucky because we can just use completing the square to see what the minimum value is, or we can use our, I don't like saying this, but we can use our brains. Because if we have a look at this function, 4 minus 3x squared, and if you do completing the square, you'll come to the same conclusion to me. What are the range of values for x squared? Well, x squared has to be bigger than 0, right? It can never be negative. Which means the smallest value this can be, the smallest value x squared can be, in fact I should say bigger than or equal to, the smallest value it can be is 0. So if I sub that in, I know that f of x has to be less than 4 take away 0 has to be less than 4, less than or equal to 4. Why do I know that? Well, if you think about it, as x squared gets bigger, we're subtracting a bigger number from 4. So for example, if x is 1, we get 4 minus 3 times 1 squared, we get 4 minus 3, which is 1. When x is 2, x squared is 4, 3 times 4 is 12. 4 minus 12 is minus 8. Can you see how it's going to keep getting smaller and smaller and smaller? So the biggest value this can be is when x is equal to 0, which is when this equals 4, this whole thing. Again, if you did completing the square, you would find the exact same thing as me. You'd find that the maximum value is 4. And since it's a maximum, it means everything is less than or equal to it. The other thing you could do is you could literally sketch the graph. That means our domain into g of x is less than or equal to 4. Because again, the only values we get from f of x are less than or equal to 4, which means the only values we sub into g of x are less than or equal to 4. So let's work that out now. If I sub that in fact, let's scroll down a little bit. If you notice, I'm not even using this equation, by the way. I'm not even using it. You don't need it. 5 over 2x minus 9. And we're subbing in values of x which are less than or equal to 4. Well, that means if I sub in 4, we get our biggest value, right? So when x equals, so g of 4 equals what? So we get 5 over 2 times 4 is 8. 8 minus 9 is minus 1. So we get 5 over minus 1, which is minus 5. Okay, cool. As I make this smaller and smaller and smaller, so let's say x is 3, then we get 2 times 3 is 6, minus 9 is minus 3. So it gets bigger. In fact, another thing that you might want to do is, I sometimes like to even draw out a table, like literally sub in a bunch of values for x and g of x. So we get 4, 3, 2, 1, 0 going on. I sometimes even pick like a really, really big number just to finish off on. So when it's 4, we get minus 5. When it's 3, what do we get? We get 5 over 6 minus 9. 6 minus 9 is minus 3. We get minus 5 over 3. If you want, you can convert that to a decimal if you want. That's what, minus 1.6? Yeah, 1.6. So in 2, we get 5 over 4 minus 9. 4 minus 9 is minus 5, so we get minus 1. So in that, we get 2 minus 9, we get 5 over minus 5 over 7. Can you see how we're actually getting closer and closer to 0? Now the question is, will this ever level off? So if I look at the difference, we go from minus 5 to minus 1.6, that's a difference of 3.4. Then we have a difference of 0.6. Now what's 5 over 7 again? I actually can't quite remember. Oh my god, where did the time sign come from? Did I click that? Then we get a difference of 0.3. So can you see how the difference each time is getting smaller and smaller and smaller? That implies that this is going to level off. And if you think of the reciprocal graph, because this is a reciprocal graph, it does level off. It never reaches a value. So what happens when we sub in just a ridiculously large number, like minus 10,000? What happens? 5 over 2 times minus. We might even want to go bigger than this. Okay, it's getting smaller and smaller and smaller. Let's keep subbing in values. Okay, so it seems to be leveling off on a specific value. Let's just keep making bigger and bigger and bigger. Can you see how it's getting closer and closer to 0? Add a couple more zeros. Closer and closer to 0. So that means this graph is approaching 0, but it's never quite reaching it. So that means the biggest value it can be is 0, well, less than 0. So our range of values here is it goes from -5, less than equal to gf of x, less than 0. So again, the strategy here for doing things like ranges, it is quite nuanced because there's a bunch of different things you can do. You can use completing the square if it's a quadratic. You can use technically differentiating for certain things as well to find minimum and maximum points. But just be aware that that doesn't find global minimum maximums. What I like to do is find the range of the function I'm inputting, which is f of x, then sub that in for the domain of g of x. If it's a fraction, I'm going to tell you this right now, if it's a fraction, it always levels off on a certain value. The value might be 0, it might be 2, it might be 1.5, but it always levels off because it's a reciprocal graph, right? So reciprocal graphs always level off at some point. So that's one thing you need to keep in mind. If it's a fraction like this or like this, any kind of fraction will level off, especially if x is in the denominator. Then sub in the values that you get given from that. Anyways, I know that was like a very, very, very long way of doing the question, but now you know how to do it. Hopefully you'll be able to do that a lot faster in the real thing. I can do it quite quickly. It's just that I wanted to explain everything first. We have h of x is this. Find the range of values of x for which these two things are equal. So f of x was 4 minus 3x squared. Let's find that. So we have 4 minus 3x squared equals 2x squared minus 6x plus k. A few different things you can do. In fact, quite a few different things that you can do. You can use the trick that I had before, which a few questions before, where I sketch them both out and see where they intersect or how they can intersect, which would be quite powerful because remember what the plus k does is it just moves things up and down. Now, let's have a think. And so yeah, just left off with this. Now, reading the question again, very important. We can have a look at that and we can sketch the graphs to see when the range of values are, but it says here for which it has no real solution, so basically where they don't intersect. So if it's a minus 3x squared graph, we're going to have like a sad face and we're going to have a happy face for this one, and we're just looking for the values of k for which okay, fine, for which this thing doesn't actually intersect anything. So what I mean is, as we increase k, it's going to move up and up and up and up and up. So at some point, they're no longer going to intersect with each other because the graph has been shifted up too much. So a good way to do this, though, is when it says no real solutions or two real solutions or whatever, a good thing to use is the discriminant because it's a quadratic. Now, a common mistake students make, again, I'll move everything to the right-hand side while I'm yapping. A common mistake that some students make is they use this for equations that are not quadratics, which is not a good idea. So if it's no real solutions, it means that it is less than 0. B is going to be negative 6, so we have negative 6 squared, minus 4, A is 5, C is k minus 4. 6, that would be minus 20k. And that's minus 20 plus 80. Let's move the k over to this side and combine those two. That's what, 116? So divide both sides by 20. I think, is that going to be 5.8? Yeah, divide it by 10, 11.6 and half it, yeah, obviously. And there you go. That's your solution. And again, that's where these two curves will no longer intersect. So normally they'd be down here. Then as you increase k, they're just about to intersect, and now they'll never intersect again. So always think about looking in terms of sketching graphs to find out solutions. First three terms of a geometric sequence are this, this, and this. Where k is a constant, using algebra and making your reasoning clear, prove that k is 5 over 2. Well, if it's a geometric sequence, that means that if I divide any of these two adjacent terms, they should give me the same common ratio. So in other words, if I do 9 to the 7 minus 2k over 3 4k minus 5, that should be the same as 3, I'm going to say 2k minus 2, I don't know why it's in brackets, that's disgusting, 9, 7 minus 2k. They should be the same. And then all I have to do is show that k is 5 over 2. Okay, so what I'm going to do is I need to make all the bases the same. So 9 is the same as writing 3 squared. So if I put that in, we get 3 squared to the power of 7 minus 2k over 3 4k minus 5 equals 3 2k minus 2 over 3 squared 7 minus 2k. Now we can expand that, so we're going to times, so when you have a power to the power, they multiply each other. So 3 to the 14 minus 4k, that's meant to be a k, over 3 4k minus 5 equals 3 2k minus 2 over 3 to the 14 minus 4k. Now we can subtract them because they're being divided. Wonderful. So here we need to be careful here because it'd be 14 minus 5, right? So it becomes 19. Then it's minus 4k minus 8k equals 3. 2k minus 4k, so 6k. Minus 2 minus 14 minus 16. Now because the bases are the same and these two sides are equal, it means their indexes should also be equal. Well, actually indices. Each index should be equal, I should have said. It was 6k minus 16. I'm going to move the k's to the right hand side, the numbers to the left. 19 plus 16 would be 35. So careful with some of the maths sometimes. And that would be 14k. Divide both sides by that, we get 35 over 14 equals k, which if I divide top and bottom by 7, I get 5 over 2. Yay. Whoop-de-doo. Then it says, hence find the sum to infinity of the geometric sequence. So if you remember with sum to infinity, what the equation is, it is s infinite equals a over 1 minus r. So the two things we need to work out are the first term, but we know k is 5 over 2. Oh, that's going to be such a nasty number, isn't it? Ugh. 3 to the power of 10, right? Oh, it's just 3 to the power of 5 then. Never mind. Never mind. What am I complaining about? 243. Cool. In terms of the common ratio, I should be able to sub in k for either side because both sides are equal. Let's just do the left-hand side, why not? Alright, let's be careful here. So I'm going to do it for the left-hand side, so that's 9 to the power... That's not a power button, Mitchell, come on. 9 to the power of 7 minus 2k. But remember, k is 5 over 2, so that's minus 2 times 5 over 2, so minus 5. I didn't put the fraction. Please? There we are, cool. 3 to the power of 4k we discovered was 10, so it's 10 minus 5. A third. Oh, that's nice. So sum to infinity. Again, that's for 3 marks, that's not bad. 243 over a third is the same as 243 times 3. You know what? It's too early in the day for me to do mental maths. 729. Hang on, it's 1 minus. Oh my god, that was tragic. So that means my answer should be 2 times that. Sorry, divide that by 2. You know what, screw it, let's just do it like this. So that's over 2/3 now. Yeah, so the same thing, just over 2. Not bad, not bad at all. I think that's quite a decent question. Here we have a graph, and it looks like an integration question, everyone's favourite. So, we have figure 3 shows path the curve with the equation 8x minus x 5 over 2, crosses the x-axis at point A, verify that the exponent of A is 4. Now, verify is a very interesting keyword, and there's a 2-mark verify question that came up, and I had quite a few students that were trying to calculate it instead. So it's very tempting to work out, sub in y equals 0, then factorize and find the points, right? Now in this case, that doesn't take too long, so it's really not the end of the world if you did that. It doesn't take very, very much time at all. But there was a much harder one involving trig identities before. And again, it's 2 marks, and if you wanted to prove it, it would take you like 5-6 marks worth of effort. Verify means check. So all you need to do is sub in x equals 4 into the equation and show it equals 0. That's all they are asking you to do. Now, I would recommend, because, and I'm going to talk about this in 2 seconds, this is really, 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 really important. You have to sub it in, and this here is so important. So I had a meeting, just so you're aware, I'm recording this in like July of 2025. A couple of weeks ago, I had a meeting with one of the examiners from Edexcel. So one of the head examiners come and they talk to all of the A-level teachers in my borough about maths and stuff. And they basically said, for this, you have to treat it as if it's a non-calculator paper. So you are literally not allowed to use a calculator. So let's say there was a quadratic that needs solving. You have to show you factorizing for the solution. Otherwise, they give you 0. So later on, when we do the integration, I'm not allowed to check anything on a calculator. You treat it as if it's a non-calculator paper. Apparently, a lot of students lost marks from that, which I think is a bit unfair, but what I think is completely irrelevant. So I'm not going to worry about that. Just be really careful when you do that. 8 times 4 is 32. That's going to be 2 to the power of 5, which is also 32, so it equals 0. Verified. Cool. The line L1 is a tangent to the curve at A, here. Use calculus to show that an equation of the line is this. So tangents mean that the gradients are equal. So all we're going to do is we're going to differentiate y. And hopefully you can see why we're doing that. Yeah? Anyways, do r by dx. Nice and easy. We just take, move the 1 to the front, take 1 away from the power. So that's just 8 minus 5 over 2 x to the 3 over 2 if I minus 1 from the power. Cool. Then the x-coordinate is 4 at that point, so we're going to sub in x equals 4. That's going to be the same as our gradient for the tangent, because remember, at that point, the gradients are equal. And again, no calculator. So if I square root that, I get 2. 2 cubed is 8. So if I divide that, that'd be 4. 5 times 4 is 20. So it's 8 minus 20, which is minus 12. Which makes sense because we have a 12x here. So if we use y equals mx plus c now, we get y is equal to minus 12x plus c. Now we need to find a coordinate. Now, I don't have a coordinate just yet. A is, the x-coordinate is 4. I could sub that in, but remember we already verified that the y-coordinate is 0, so why don't we choose x equals 4, y equals 0. So we get 0 equals minus 12x plus, no it doesn't, 12 times 4, come on Mitchell. So that means c is equal to 48. So we have y equals minus 12x plus 48. And they want it in this form where all they've done is they've moved the 12x over. So it's nice and easy. You do have to move it over, otherwise you lose the final mark. They're very, very picky. Not bad. That wasn't too crazy. Line L2 has equation y equals 8x. The region is bound by the curve and both of these lines. Use algebraic integration to find the exact area of R. So the first thing I would do before then is I'll try and work out what bits I actually need. So I'm going to write that as 4, by the way. Now, when I'm integrating, I'm going to have to find the area underneath both of these lines. Now, I can't do one integration for that because they are 2 different equations. So what I need to do is, I could actually just use the area of a triangle formula if I wanted to, but essentially I need to work out the coordinates where L1 and L2 cross. That will give me the height and the base of these 2 triangles, which would be useful. And then from there, once I work out the area of this big triangle, I can just subtract the area underneath the curve, which is the integral between 0 and 4. Cool, wonderful. What were the two equations again? I'm going to use the one before. Y equals minus 12x plus 48. And the other one's y equals 8x, if I'm not mistaken. Yeah, so if you make them equal to each other, let's find out where they intersect. That is meant to be a minus, plus 48. So we have 20x equals 48. So x equals, so divided by 10, 4.8 divided by 2 is 2.4. So the x coordinate is 2.4. Which means the y coordinate, if I sub that into this equation here, is 8 times 2.4. I probably shouldn't have. What's a good way to do this? So that'd be 16 times 0.4. That's a good question. So it would be 16.4 added on, that'd be 19.2. To be honest, if you used your calculator just to times two numbers together, I'm sure they won't notice, so that's fine. So the coordinates there are 2.4 and 19.2. So let's work out the area of the triangle first. So the triangle, because again, don't forget they want it as an exact value. It's going to be a half. The base, it goes from 0 to 2.4 first, so it's going to be a 2.4 base. Times the height of, what did we get? 19.2, yep. And then we're going to add on a half. Now the base is 4 minus 2.4, which is 1.6, times 19.2. Now that, again, I'm sure will be completely fine to put on a calculator. Come on, that'd be... Uh, 19... Oh. See those shaky hands? I'm getting too excited. The adrenaline. Yeah, there's no way in hell they'll just expect it, because it's just like mental maths, it's pointless. We get 100, in fact, let's leave it as a fraction because they said exact value. And now we need to do the integral, because so we're going to subtract is 192 over 5 minus the integral between 0 and 4. Look at that integral sign. Oh my god, that's beautiful. 0 and 4 of the curve, which is 8x minus x to the 5 over 2. 8x minus 8x minus x to the 5 over 2 dx. So that would be 192 over 5 minus, that would be 8x squared divided by 2, so 4x squared. Add 1 to the power is 7 over 2. Divide by the new power makes it 2 over 7. And because one of the limits is 0, we only actually need to sub in the 4, because if I sub in 0, can you see the whole thing is 0? So let's just sub in 4. Oh, this is going to be disgusting. I absolutely love Edexcel, you know? Like, it's such a good example. So 4 squared is 16 times 4 is 64. Right, so the square root of 4 is 2. 2 to the power of 7, so that'd be 2, 4, 8, 16, 32, 64, 128. Fantastic. And then double it again, so that'd be 256 over 7. Can you divide 256 by 7? You know what, I'm doing that on a calculator. I don't think you can, right? It's in... No. Alright, thanks, calculator. Let's just do 6... Come on. Oh, okay, so the same... Okay, that's interesting. Minus 192 over 7. Yeah, cool. Yeah. Surely they'd let us... Surely, right? If not, I'm sure you guys know how to do add and subtract fractions. I'm gonna just, like, surely they'll let me just like minus 2 fractions, right? 384 over 35. I'm so glad that they made this non-calculator. You know, like, it's really, really useful. And that's 5 marks. So not too bad. Yeah, the non-calculator bit is a bit annoying, but Who knows? In the future, they're thinking of maybe doing a non-calculator paper, which would be interesting. It'd certainly clear up a lot of issues. But yeah, perfect. Move on to the next one. Okie doke. This is a fun question. So, design of a badge. They had a shield, I think, last year or something like that. Something, I don't know, something weird anyway. And yeah, so it's bound by the arc and all that fun stuff. Cool. The common mistake I see here is people doing the area of the semicircle, and they do minus the area of the sector, or minus 2 times the area of the sector. That's not quite right, sadly, because if you look at this shape, it's not actually just a sector. It's 2 sectors stuck together, which is annoying because you also don't want to double count the area of the sector, which sucks. Now, it says here OB is the arc with center A. So if I draw in this, that's the arc they're talking about. So I can use the area of that sector where the radius is 5. That's also 5 and that's also 5. That's fine. But if you notice, I need to also add on the area of this little arc here in order to get the whole white area, which is a little bit tricky. That was kind of strange. I think it just crashed. Anyways, so we need to also work out the area of this little segment here. That way we have the entire white area. So we're still going to do the area of the semicircle minus the white area, but the white area is not just a sector. So let's, we can gain some quite easy marks by just doing the area of the semicircle first. So semicircle is just pi r squared over 2. Remember that r is going to be 5, so we're going to have 25 over 2 pi. And remember, it also says exact area, so let's leave it as that for now. Now the area of the blue sector, that's also quite easy. The only thing you have to remember is that this angle is always going to be 60 degrees, or pi over 3 radians. Would it be worth doing it in radians? It doesn't actually make a difference, it's fine. So let's do that. So let's do sector equals, so it'd be 60 over 360 times pi r squared, so pi times 5 squared. 60 over 360 is a sixth, so that's going to be 25 over 6 pi. And again, that's what we're going to subtract these two in a second. Then we have the segment. Now the segment is going to be a little bit interesting, bearing in mind that we have to do the area of the triangle. So hopefully it's clear. So in green. Hopefully it's clear that this is also a triangle and that's equilateral. Now, that's also why we can make that 60. So this is also 60 degrees. Now, we're going to do the area of the triangle. The area of the sector minus the area of the triangle. Now, I don't need to work out the area of the sector again because I've got it. Now, this isn't this blue sector. It's the other sector, but it's the same length. So we're going to do 25 over 6 pi, because I don't need to work it out again, minus, and again this is where we get the red part, minus the area of the triangle, which is half AB sine C. So half 5, 5, sine 60. Okay? If you've got what that is, you can use a calculator, but it should just be, what, root 2 over 2, root 3 over 2? Also, before you do all this stuff, obviously make sure that you're in the right mode for your calculator. You're in degrees or you're in radians, depending on how you want to do it. But yeah, it's root 3 over 2 for this. So this is going to be, again, just for the segment, it's going to be 25 over 6 pi minus, 5 times 5 is 25, so it's 25 over 2. So 25 over 2. And then it's also going to be times root 3 over 2. So that's just going to be, okay. So now, what are we subtracting? We're doing the semicircle minus the sector plus the segment all together. So, we're going to do 25 over 2 pi minus the sector 25 over 6 pi plus 25 over 6 pi minus 25 root 3 over 2. Does it say that the... We can do that. Because if it's a, then a can be a fraction. So 25 over 2 is our fraction in front of root 3. That's fine. Did it say they're integers? No, they're just rational numbers. Okay, cool. So add those two together, we get 25 over 3. So we have 25 over 2 pi minus 25 over 3 pi. If you're not sure, you could just do 25 over 6 plus 25 over 6 and you get the same thing. And then it's going to be plus 25 over 3 over 2 root 3. The reason why I've written it like that is just because the answer over here is written like that. So now, what would 25... You know, I don't have to... I just remember, this isn't a calculator thing. This isn't the weird ones where it says don't use calculators. So we get 25 over 6 pi plus 25 over 2 root 3. And if we want to write it in that exact form, that means it's 25 over 2 root 3, where this is equal to a, plus 25 over 6 pi, where this is equal to b. Wonderful. So again, a little bit tricky when it has something like that, when you have the little sectors and segments that you have to deal with, but be really, really careful. Make sure you don't just assume that this is like a sector by itself or something weird like that. So for this question is a trig modelling question, which everyone absolutely loves, of course. But the first part is always the same, where they give you the r sine or cosine theta, but this time they've changed it to a k. Oh my god, crazy, right? Now the way I do this is I don't memorize the method because, again, I don't really believe in doing that. I think that it makes your life a bit harder in the exam, especially because what if you misremember slightly, right? What if a sign is slightly different or something like that? Instead, what I like to do is just use the addition formulae to work out what the answer is. It is technically slightly longer, but again, it requires absolutely zero memorization. Now, because it's cos theta plus alpha, we can just use the cos addition rule to work that out. So it's cos theta cos alpha minus k sine theta sine alpha. And now all we're doing is we're comparing coefficients. So everything in front of cos theta on this side should be the same as everything in front of cos theta on this side. So on this side we have 140 cos theta should equal k cos alpha cos theta. So again, we can kind of just compare the coefficients. And we can do the exact same thing with the sines. So we have minus 480. Again, everything in front of sine here is minus 480. Everything in front of sine here is minus k sine alpha. And then cross those two off. So we can work out the angle now by just dividing these two equations by doing 1 over 2. If I do that, I get k sine alpha over k cos alpha equals 480 over 140. So that's just tan alpha. I'm going to leave it as that because I don't really care. And we can just work out what alpha is by just doing the inverse tan. And this is in degrees, so let's leave it in our degrees mode. So inverse tan 480 over 140 gives me 73.7 degrees. Actually, did it say 2 decimal places? Yeah, it does. 73.74. Yeah. Cool. And then for the r value, or in this case the k value, it is just about squaring and adding these two values together. I can show you where that comes from if you'd like. So when you have your value of like sine alpha, for example, it's just going to be k squared sine squared alpha plus k squared cos squared alpha equals 1. Then we can just sub in the values for sine and cos alpha, which is completely fine because we know that it's 140 and 480 respectively. Or you can just do this. So again, I don't personally like to memorize stuff, but again, if your memory is very good, then why not? That's totally fine. And that gives you 3 marks. Very nice. The one thing I would do after this, though, oh, 500, that's really nice, is I would actually write out the final form so that it equals 500 cos theta plus 73.74, just because then you can more easily recognize it later on and it's easier for the examiner as well. I know you might not like the examiner, but we do want to make their lives easy so that way we can get some extra marks. So the scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits is modelled by this equation, where t months blah blah blah. Given that the maximum number of rabbits is 1500, find the complete equation. So first thing you might want to notice is this is essentially the same as this, but theta is 30t now. That's the only difference, which is fine. Now, something to keep in mind is they don't always make it exactly equal to. They might have done this as like 280 and 960, for example, in which case it will be double this value for cos, as an example. So you have to compare it. It's not always going to be the same. So I could write r as a plus 500, and again, instead of theta, we're just using 30t. And now it says that the maximum number of rabbits is 1500. So what does that mean? Well, it means that the biggest thing this whole equation can be is 1500. So if I have a look at this equation, some people try and like differentiate, and you know what, differentiating does work, and then solving it and doing all that stuff, but there's a far easier way to do it, and that's this. The cos graph goes between -1 and 1. And so in this case, if I want to make it as big as humanly possible, I would want cos to be equal to 1. If cos is equal to 1, that means this whole part over here is equal to 500. If that's equal to 500, and I know that the maximum is 1500, that means A has to be equal to 1000. Because it'd be 1000 plus 500 gives me 1500. Again, cos goes between -1 and 1, so its maximum value is 1. If this whole cos thing equals 1, then it's 500 times 1. Then part 2, it says, hence write down the minimum number of rabbits. Okay, again, some people might think about differentiating or something like that. Forget that. All we need to do is look at this. How do I make this equation as small as humanly possible? Well, if cos was -1, that would be the smallest value that r can be, right? When cos is equal to -1, because then we get a minus 500. So, I know that a is 1000. If cos was -1, then that means that's plus 500 times 1, so it's minus 500, which means the minimum number of rabbits is 500 rabbits. See, again, it's a 2-mark question, so it's meant to be very quick and snappy. You should be able to deduce the value, so not working anything out. In fact, we can probably do part C over here now. Part C. The actual number of rabbits in the wood is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. Okay, here's what I would do. The first thing that I would do is I would try and work out, and when it says middle of April, what does that mean? Well, if you remember what T is the number of months after the start of the year. And if you know your months of the year, it's January, February, March, April. So if we're in the middle of April, then that's 3.5 months, right, after the start of the year. So if I sub in t equals 3.5, I should get a number very close to, if not equal to, 500. So let's have a look. So when t equals 3.5, and again, you need to write this out because, again, the examiner needs to see what the hell you're doing, right? And imagine you're trying to teach it to someone else. That's the way I like to do this. So if 1000 plus 500 cos 30 times 3.5 plus 73.74. Again, if this gives us a number very, very close to 500, which is our minimum number of rabbits over here, then it is a reliable model. If it's far away, then it's not. Cos 30 times 3.5 okay, so 500.1. That obviously we can't have 1/10 of a rabbit. Hopefully, anyway. So when we round it, it's 500 rabbits. Therefore, it's reliable because it's close to the actual minimum, right? So the actual minimum is, the minimum according to the equation is 500, and the minimum number of rabbits is in the middle of April, and we got the minimum value of 500. So because those two values agree, then it is a reliable model. The number of foxes during the same year is modelled by the equation 100 plus 70 blah blah. The number of foxes is at its minimum value after t months. Find, according to the models, the number of rabbits in the wood at time t months. So what we're going to try and do is find the minimum value of foxes, so what time that happens, that's what t is, then just substitute it back into our original equation. Now again, the good news is, if we have a look at this, if we want this to be a minimum value, we want sine to be -1. And now my question to you is, when we have sine 30t plus 70 equal to -1, when does that happen? Now you can just use inverse sine, by the way, that's completely fine if you want to. Or you can use the graph, right? I like using the graph personally. It equals -1 at, not minus, at 270 degrees. So in other words, 30t plus 70 should equal 270 degrees. So if we work out the time there, I think it's going to give me a decimal, which is a bit nasty, but that's, you know, it's the way the cookie crumbles, right? And divided by 30, it's definitely going to 20 over 3. Let's say 6.67, or should we keep it as the exact value? You know what? 20 over 3. And all we're going to do is sub that back into our original equation. Again, for the number of rabbits. So we have 1,000 plus 500 cos 30 times answer plus 73.74, close bracket. I get 1032.6. So you can round that up or down if you'd like, but I think rounding up makes a little more sense. And there you go. Not bad. Again, plenty of places to make small mistakes, but if you take it slow and you really think through it, you should be relatively okay. Okay, of course we have to have a slightly trickier integration question because we haven't really had a tricky one just yet, although paper 2 has a lot more of that kind of stuff. We've given that a is a positive constant. Cool, use the substitution x is a sine squared theta to show that this equation can be written as a much nicer integral over here. And then we have to use the integration to show that equals k pi. Cool. That should be nice and fine. So, part A, substitution. If you're stuck, I'll just go through the steps. What I mean by that is, you know that you're going to have to differentiate what you're subbing in, right? So we're going to have to do dx over d theta. Now, differentiating this, you need to recognize that it's a chain rule question, right? So if y is equal to sine squared theta, that's the same as sine theta all squared. And if you remember the shortcut when it comes to doing the chain rule, you bring the power forward, you differentiate what's on the inside, so cos theta, and then you write the exact same thing again, but you take away 1 from the power. So if this was a cubed, for example, this would be 3 cos theta sine squared theta. But because it's a 2, that's why it doesn't. There you go. That's why it doesn't have a power anymore. So this becomes 2a cos theta. Do we want to keep the sine theta there? You know what? It doesn't really matter which way around do we write it. It's all good. And since we know we're going to sub it in for dx, let's just times the dx over. This is always my first step because you might find that certain things cancel out, which is nice. Let's sub it into here. We can also sub in. Actually, we can sub in everything because we don't need to rearrange this. Okay, so in this context, we can actually sub it in normally. So that's 0 to a. That's not as good as my last one. So that'd be the square root of. So if it's x to the half, that'd be square root a sine theta, because if we square root that, right? Do I want it as square root a or as x to the half? I want to do it as, as a to the half. I want to do it as a to the half. Sine theta times, and I'm going to put this as a bracket to the power of half as well. So a minus a sine squared theta to the power of a half. Then it's times by 2a sine theta cos theta. Cool. Let's do the a to the half times 2a. That would be 2a to the 3 over 2 And I'm basically gonna take that out to the front. So 2a to 3 over 2, integral between 0 and a. Now that's going to be sine theta, that's going to be sine squared theta, cos theta, then it's a minus a sine squared theta to the half. We can actually factorize out an a from here, so we factorize out an a to the half. If I add that to the front, 3 over 2 plus a half is squared, right? So it's 2. So it's 2a squared. And again, all I've done is I've factorized out an a from inside that bracket. That's sine squared theta, cos theta, 1 minus sine squared theta to the half. I forgot to actually write the d theta, lol. Cool. 1 minus sine squared is cos squared. Then it's square rooted, so it's just cos. So this is sine squared theta, cos squared theta. Excellent. So let's see actually what we're trying to make it equal to. We're trying to make it equal to sine squared 2 theta. Now, if I have a look at that, that's a 2 theta. This is just theta. So they've used the double angle formula. So let's write out the double angle formula for sine 2 theta. Sine 2 theta is equal to 2 sine theta cos theta. Now that does look similar to this. All they've done is squared both sides. So if I square both sides, I get sine squared 2 theta equals 4 sine squared theta cos squared theta. Now that looks really similar to what I've got, but what I've got is 4 times too small, right? If you want, let's divide both sides by 4. We get a quarter sine squared 2 theta equals sine squared theta cos squared theta. Now that looks exactly like I've got. So have you noticed what I did just now? And this is part of your exam technique. Whenever you're doing trig identities, anything where you're showing one side equals the other, use the answer to get the answer. Okay? I was about to make a joke about Thanos for a second. Anyways, so we're using the answer to get to the answer. It says 2 theta. Well, what's 2 theta? Well, it's the double angle formula. Okay, that looks kind of similar, but what's the difference? Well, it's been squared, right? Like in our answer, it's squared. If I square both sides, what happens? Well, I get something that looks really similar to this. Really similar. And if you notice in the answer, it's a half a squared. Here we have 2a squared, but we have a quarter. 2a squared times a quarter is a half. So there we go. Are we done yet? The answer is no. Was it just sine squared 2 theta, right? Yeah. Because one more thing. The limits. Whenever you use a substitution, you have to change the limits. Now, again, that means if I stopped there, I would have lost a mark, which is a shame. We need to do the limits to get the 4th mark. So when x equals 0, let's sub them in up here, for example. If we have 0 equals a sine squared theta, we can just cancel out the a. So sine squared theta equals 0. If I inverse sine that, I get 0, right? So do I want to square? Yeah, square root both sides. We have sine theta equals 0. When does that happen? That happens when theta equals 0. So the bottom limit stays the same. Now let's sub in a. So we get a is equal to a sine squared theta. Divide both sides by a. We get 1 equals sine squared theta. So we get sine theta equals 1. So theta equals 90 degrees. In fact, is this meant to be in radians? Yeah, it's pi over 2, which is the same as pi over 2 radians. So there we go. And that's it. Not too bad at all. I quite like that question. And again, you're extremely likely to get something like that in your exam. And look how beautiful this looks, man. Look at it. It expands, gets fat and ugly, then it slims down again. I love it. Oh, maths, man. What a beautiful subject. All right. Anyways, hence use algebraic integration to show that this equals k pi a squared. Cool. So all we're basically doing is integrating sine squared 2 theta. And that's basically it. So let's see what we get from that. Now, you might know that you can't actually integrate sine squared. So what's the trick? What's the technique? What's the ability? What's the trick that we have to use to integrate this? Well, we know we can't integrate a sine squared or cos squared or something like that. So we have to change it to something we can integrate. Now, I'm looking at this, and I'm looking at the fact that we've already used the double angle formula. So I'm suspecting that there's going to be another double angle formula that we can use. Now, which double angle formula has sine squared in it? That is the one for cos 2 theta. Now, the only problem is we already have 2 theta. So what's double 2? 4. So cos 4 theta would give me 1 minus, and, well, actually, you know what? No, I'm going to do this properly. Cos 4 theta, because I don't like memorizing stuff. If you remember the double angle formula from before, it would be cos squared minus sine squared. So we're going to have cos squared 2 theta minus sine squared 2 theta. Now again, we want this in terms of just sine, because sine is the only thing we have. So we can change cos into 1 minus sine squared. So that gives me 1 minus sine squared 2 theta minus sine squared 2 theta, which gives us the bit at the top. Again, I don't like memorizing these things because, again, some people the question I get asked is, how do I know it's 1 plus 2 sine squared theta? Is it 1 minus 2 sine squared theta? Same with cos. So I prefer to just work it all out manually. Which means if I rearrange this for sine squared, what do I get? Well, I get sine squared 2 theta equals 1 minus cos 4 theta over 2. Can I integrate cos? Yes, I can. So this just becomes the integral between a half a squared, 0 to pi over 2, of 1/2 minus a half cos 4 theta. Yay. That's a lot easier to do. Mother of God. Alright, now let's do this. My hand's getting a tiny bit tired, I'm not going to lie to you. So, we get a half theta over there. Here, if you remember cos, it integrates to just sine, so that means it's still negative. You differentiate what's on the inside, so that becomes 4, because 4 theta differentiate becomes 4. And you divide by the new thing. So it's a half divided by 4, which is an eighth. Sine 4 theta. And then we're subbing in pi over 2 and 0. A little bit more algebra and we're done. Just a little bit more. And for the first thing, we get pi over 4. Now, pi over 2 times that would be sine 2 pi. Sine 2 pi is 0. So that's it for that one. When I sub in 0, I get a half of 0, which is 0. Sine 0 is also 0, so I get minus 0 as well. Cool. So that just gives me... What was the actual answer? K pi a squared. Okay, so K would have to be an eighth then. How do I know it's an eighth? Because it's a half times a quarter. Then it was the pi a squared, right? Yeah, there you go. Look at that. 8 marks of beautiful integration. And just look at it. Look at the layout. Oh, I love it. It's so cool. Yeah, 2 more questions and then we're finally finished this paper. I know it's been a very long video, so well done for getting through all of this. Fairly tricky topic. Second last question as well, so it kind of makes sense, where it's differential equations that you then have to solve and do all of that fun nonsense. So a balloon is being inflated in a simple model. It's modeled as a sphere. Cool. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. So it's going to be dr by dt. It's going to be positive because it says increase. If it said decrease, you'd shove a negative in front. And then it's k over, I think it said r squared, right? Square root, sorry. So it's square root of r. There we go. And that's it for part A. And it gives us some additional information. So right at the instant when t is 10, the radius is 16, the radius is increasing at a rate of 0.9, blah, blah, blah. Solve the differential equation to show that. Okay, so because it says, so first of all, we can work out what k is, right? The radius is increasing at a rate of 0.9, so that means this is 0.9 when t equals 10, but we don't actually... When t equals 10, but we don't have t, but it also says the radius is 16. so I can sub that in as well. So that becomes 4, so 0.9 equals k over 4, which means k is equal to 3.6. So that's the first part of the differential equation solved, right? We have that constant. Now, to solve a differential equation, we then have to integrate. So if I move the t over to the other side and the r over to this side, we have square root r. In fact, I'm going to make it r to the half because we're going to be integrating in a second. dr equals k, which is 3.6 dt. Now if we integrate both sides, add 1 to the power divided by the new power gives us 2 over 3. So add 1 to the power gives us 3 over 2. When we divide by 3 over 2, keep flip change is 2 over 3. R to the 3 over 2 equals 3.6 t plus c. And wonderful. So from that we can still use this information to work out the plus c. When t equals 10, r is 16. So we have 2 over 3, 16, 3 over 2 equals 3.6 times 10 plus c. So 16 square root is 4, 4 cubed is 64. 128 divided by 3. I don't think you can do 128 divided by 3. You know what, why am I doing it in my head? Let's just use a calculator. Right? Why do hard thing when easy thing exists, right? Oh, fingers were slightly too short there. Oh, you can't do it. Yeah, perfect. Well done, Mitchell. You're amazing. Which means c is equal to that minus 20 over 3. Cool. So we have 2 over 3, r to 3 over 2. What did I say it was? 20 over 3. Does it say... Ah, we just have to show that equals that. That's not too bad. Equals 3.6t. So how do we show it equals that? Well, if you notice, there's nothing in front of r in this case. So we're going to divide everything by 2/3. So divide that by 2 is 1.8, times it by 3 is 5.4t. That's how I write, divide by 2/3. And so that'd be 20, that'd be 10. So yeah, we did get that correct. 5 marks. That's actually not too bad for 5 marks, to be honest. I think the most confusing part about differential equations and solving it is knowing which information to use. The answer to that is don't think too much. Sub in all of the information you can into any equation you can to try and figure something out. Part C, hence find the radius of the balloon when t equals 20. Give it to the nearest millimetre. So we're going to sub in t equals 20. We get r to the 3 over 2 equals something. So we get 5.4. 118. Then to find r, we're just going to cube root this and then square it. So cube root answer squared 24. So nearest millimetre. What is r in? It's in centimetres. So that would be to the nearest tenth of a centimetre. So 24.1 centimetres. And lastly, suggest a limitation. Well, if I have a look at this, this suggests that the radius of the balloon will just increase forever, right? Whenever you're finding a limitation, the best thing to do is find extreme values of stuff that you're subbing in. So if you're subbing in values for time, make time equal to 10,000. If you're subbing in for length, again, sub in length equals 10,000 and see what happens, see if it makes sense. In this equation, will the value of r ever level off? Well, it's a linear equation, right? Like, it's just going to keep increasing forever. Is that viable for it to increase forever? So I would say that model suggests that the radius infinitely increases, which is not true. What else could you do? The other thing you could do is you could talk about the situation itself. So this is different for every single question. So it could be, for example, there's algae on a pond was one question from 2023, I think it was. You know, it suggests that it grows indefinitely and covers it when there might be a limiting factor. So you can talk about, in this case, the balloon might burst as it is blown up, something along those lines. But again, you can either apply something to the situation specifically, or you can just talk about the maths behind it. I think the maths is slightly easier in most cases, But if there's a case where you know a little bit about the situation and you can think of something, then by all means do that. You can also put more than one thing, as long as you don't contradict yourself. And finally finishing with some proof. This first one is quite nice. If it's a quadratic and they show that it's positive, they're saying show that it's greater than 0, I would just use completing the square. So we have here k minus 2 all squared minus 2 all squared plus 5. If I simplify that, we get minus 4 plus 5, which is plus 1, which is greater than 0 always, because this is bigger than 0, right? That's always a positive number, bigger than or equal to 0, and because we're adding 1, it's always bigger than 0, right? So again, because this is always bigger than or equal to 0, in fact, I don't know why I wrote k, because this is always bigger than or equal to 0, then if we're adding 1, that all has to always be bigger than 0. Now, for part 2, this question was the most frustrating question in the world. Not necessarily because it's difficult, but because a lot of students didn't fully answer the question because it's asking you to do so much. It's unbelievable. So we're asking, a student was asked to prove by contradiction that there are no positive integers x and y such that this answers it. So they've assumed that there are integers for that, which is true. Now what does this mean? If this is true, then it means that these two brackets have to times to 28. So, for example, it could be 1 and 28, it could be 28 and 1, it could be 7 and 4, it could be 4 and 7, it could be minus 1 and minus 28, minus 28 and minus 1, it could be minus 7, minus 4 and minus 7, yada, yada, yada. There's so many. And essentially, you need to solve all of those pairs of simultaneous equations in the same way they've done it. I'm not even joking. So again, if I just refer to the mark scheme, you get 1 mark for solving any one pair of the relevant 11 simultaneous equations. Good lord. 2nd mark for any 2 pairs of the 11 simultaneous equations. 3rd mark for attempts to solve all 5 pairs of simultaneous equations. And yeah, then you have to have a concluding statement. Therefore, there are no integers for that. When I say 10 pairs in total. By the way, the reason why there's 11 is because you have the opposite one of this one, which is 14 and 2 and 14. Then you've got the other 5 pairs of equations, and you have to solve all of them. So I might just very quickly just show you what I mean by this. In terms of all of the different equations that you have, here it is. Here it is. And you have to solve every single one of them. Yeah, it's depressing, I'm not going to lie to you. There isn't much you can do to shorten this. Yeah. This is a bit of a ridiculous question, I'm not going to lie to you. For 4 marks as well is a bit of a joke. The good news is that you do get a lot of marks without doing much. So solving 1 gets you a mark, solving 2 gets you 2 marks, and so on. So yeah, 2 out of 4 honestly would be good enough for that. But dear Lord, that was a tricky question. But that brings us to the end of this paper. Paper 2 will be coming out shortly as well as paper 3, of course, and then we're going to do every single A-level paper that has ever come out, which might take me a while, but it's going to be a lot of fun. I know this is a very long video, but hopefully you found it useful. If you did find it useful, please do consider subscribing. If you're interested in joining the A-level tuition classes that I have, or one-on-one tuition, then again, email in the description, and there's my website in the description for more information. Other than that, I'll see you in the next one.